Hello everyone, welcome back to the channel. Happy New Year. In today's video, I'm going to show you how to go from this, which is a depth map image, to this, or even change the theme entirely. In this case, sci-fi. Have another one, futuristic. We can go to fantasy. We can even change the gender and do this. As you can see, we are maintaining the same pose, the same portrait, and in all of them, it's exactly the same thing. I did all of this with a Flux control net. The Flux 0.1 Canny Dev FP8, and then we have a Flux 0.1 Depth FP8-1. These two models are going to help us use control net with Flux. Now, before we start with the Flux control net, let us talk about the Flux workflow itself. So this is a very basic text to image Flux workflow. I have the Flux 0.1 Dev FP8 version. I have the positive prop here. It's just the default prop. I have the negative prop here. We have an aspect ratio, Flux guidance, and this should be very familiar to you if you've used Flux before. And when we generate it, this is what we get. It's a good image for Flux. And in order to understand how this new Flux 0.1 Dev Canny or Depth model works, we'll need to know about this instruct pix to pix conditioning. So right now I have a very basic image to image workflow. I have an input image. It's going to give us an output image here. It goes through this instruct pick to pick conditioning and then pass to the key sampler. That also is very basic. What's happening here is that this instruct pix to pix conditioning will take the image and it will make a positive and a negative conditioning out of it. So normally when we do image to image, we pass this load image to a VAE encode, and then we pass the latent space of this image to our key sampler. Now, with this instruct pix to pix conditioning, we are instead sort of converting the image into a positive and a negative prop, and then we pass it to the key sampler. And this is the result. As you can see, this is the previous one, and this is the new one with this instruct pix to pix. Now, the reason as to why the aspect ratio changed is simply because this instruct pix to pix has a latent output, and then we are passing this latent output to the key sampler. Right now, we are not using this empty latent image, so I can delete it. Now, you will agree with me that this image is not doing anything since the output image that I've shown you previously does not look or resemble this input image at all. And that is true. That is because right now the Dev FP8 model does not know what to do with this conditioning that is being outputted by the instruct pix to pix conditioning node. So as an experiment, if I were to remove this positive prop and generate a new image, this here is the result. And now if I were to remove that input image and use the same seed, my seed here is fixed, and same thing, I've removed the positive prop. I'm still using the Flux 0.1 Dev FP8 version. Everything is same. I've just simply removed that input image. I'm also keeping the same aspect ratio as my input image. And as you can see, this is the result. It's exactly the same thing. So to understand this, the instruct pix to pix conditioning is not doing anything right now because the Flux 0.1 Dev FP8 model does not know what to do with it. In order to use this instruct pix to pix, we'll need an instruct pix model. So what the community did, actually, it's this person here, Christian. So big thank you to Christian. What they did is they took control net pre-processed images like this one. We have the Canny, there's also the Depth one. They took these images and they trained the pix to pix model on that. So basically the instruct pix to pix now knows about the pre-processed images from control net. And then they took the Flux 0.1 Dev FP8 model and they did a checkpoint merge. And now we have this combination, this checkpoint merge here, basically between Flux 0.1 Dev and then the pix to pix. So this Flux 0.1 Dev pix to pix model, you can download it from Civic AI. I will have the links in the description below. It knows what the pre-processed images from control net are, and it can generate a positive and negative prompt, and it can use those positive and negative prompt to control the final generation. So if you watch my previous video on ControlNet for SD 1.5, SDXL, and the T2I adapters, it's a different workflow from that one. Cannot use the simplified version of the workflow. Instead, we'll have to use this one where we have a load diffusion model, the dual clip loader, and then the load VAE separately. So once you've downloaded your model, you just need to place it here in the load diffusion model. Right now, I'm using the Dev FP8. The Kani version works the same way. You would just need to select it from here. The dual clip loader will require the T5XXL and the Clip L models. Of course, make sure that your type says Flux. If you do not have this node, it means that your Comfy UI is out of date. So just go into the manager, click on update Comfy UI like this. If this does not work, then you will have to update it from the folder itself. For the load VAE, you will need the AE save tensors file. I will have all the links in the description below. Now imagine that we have our model like this, and the model knows what ABC, the alphabet, are. So we have A all the way to Z or Z. And now let's make as if we want to train this model on numbers. We want to add the number 1 until 10 to the model. However, as you can see, there's no space. So if I were to add number 1, 2, it goes outside and we cannot even see it right now. So for that, we'll need to remove a few alphabets in order to replace it with some numbers. So right now I remove the alphabet Z. I can add number 1. So similarly, I can remove Y, I can add number 2, and I can keep on doing this until I'm happy with my model. Let's say right now I'm happy that I have these 5 numbers there. However, we've lost a couple of alphabets. So going back to this model, when we are doing this instruct pick to pick and they are fine-tuning it, the model is losing some information while it's gaining new information. So when we go back to our workflow here, when we use this model, the Flux.1 Dev FP8, it is actually an inferior version compared to the Flux.1 Dev model, so the full model. As an experiment, remember that when we did not have any text in our prompt and we generated an image, making sure that the seed is fixed, we got this as our output. When we use this Flux.1 Dev model and everything else is same, this is the output. So it's an inferior version, but it can do one thing correct. It can take an image, which is going to be a pre-processed image, whether it's the Kani or Dev model. It's going to go through this node here. It's going to output a positive and negative prompt. But most importantly is that this model will be able to understand these conditioning and it will be able to follow the image conditioning and generate an image as our final output. Now, if we use an actual pre-processed image, this is a depth pre-processed image, and we pass this to the instruct picks to picks conditioning. I'm still on the same seed. Again, no positive prompt. This is the result. So now we can start to see that ControlNet effect that is happening. Still, the quality is bad. I will show you how to improve it. Now we can try to add a positive prompt, and then this is the result. Now it's not exactly at the Flux quality, the original Flux model, but we are getting there now. Now, just to show you that you don't really need this latent from the instruct picks to picks, basically what is happening right now here in this node is that it's taking this load image, it's getting the image width and image height, is generating an empty image. You can basically do this manually if you need to. There is a node called empty image. So we take this, we right click, and this is a 768 by 768 image. What this node is doing, it's manually doing this, changing the empty image to be a width and a height of 768 by 768, basically the same width and height as the input image, and then it's going to automatically convert it using, right now we are using this VAE encode, and then we get an output which is latent, and then we pass this latent here. But we can very easily just ignore this output and just use any empty latent image. We can pass in our own width and height, and we are basically getting an upscale version now. So this is at 768 by 768. When we sort of do this upscaling, we are getting an upscale version. It's still keeping the outline if you're using the Canny, but if you're using the depth, you get that depth 3D-ish effect. Now, to go further, we can keep everything the same. We still have this load image here, but I changed the aspect ratio to 1280 by 720, which of course it's not correct like this. Still, it works. The image will basically get cropped and only the center part of that image will be used for the control net conditioning. So the top part and the bottom part will be basically cropped out. Now revert back to just using the depth preprocessed image as the input image. Again, the seed is fixed so that we can continue on the explanation. I'm changing the prompt here, and it doesn't matter what you put in the prompt as long as you use this depth dev FP8 one, you'll still get quality like this. So here's an example. Changing the prompt a little bit, you get like this. Again, trying to put monster in it, this is what I get. But what I would like to emphasize here is that this instruct pix2pix, it's able to get the input image and use it as a conditioning. So right now I have a bottle, and if we convert this bottle into a depth map and we generate an image using it, we get this one. You can basically see the bottle here as the outline. Everything else is basically randomized right now based on the prompt, but it is still able to restrict our output image based on that initial image. So that in itself is control net. We are controlling the final generation with an input image, but the quality with this image, with this model here, is not great at all. So we'll need to add something else in order to improve the quality. So here I am in a different workflow here, and as you can see, this one is slightly bigger. We have a second part right here. So the first section here, from here all the way to here, if I were to group it, this section is basically the control net section. We have the load image. We are going inside the instruct pix. This load image has a depth map of the bottle that we've used. I'm still using the same prompt as the previous generation, same seed. The only difference here is that I am going with only 5 steps. So instead of generating a full image, I'm basically generating a noisy image, as you can see, like this one. So we still have the shape of the bottle here. I wanted to have some anime, cartoony, alien monster tree. And from the output, you can see that it's starting to shape the monster in the form of that bottle, which is what we want right now. Now, this is the first pass where we are getting an incomplete image with just 5 steps. Now I'm passing this over to the full model, the Flux.1 dev model, and I'm doing the 20 steps. This is the usual thing that you would do with Flux. Go 20, you would use your favorite sampler, your favorite scheduler, and it's converting the workflow into a simple image to image workflows. Now, the only thing that you'll need to know here is just play around with the denoising strength on how much you want to change that image. So this is the control net section. That is the output generated, 5 steps. When we pass it over to the Flux.1 dev, the full model, this is the result. This is at 0.25 denoising strength. As you can see, we have the tree, anime, cartoony character. Now we can keep on increasing the denoising strength so that it changes from the initial input. This is at 0.5 and this is at 0.75. So right now, all we are doing is image to image. What's important is that we need to get this, which is from the control net section. All right, let's do another example. I have this example workflow. I've done a depth map of it, and I'm passing it as my input image. And I still have the same seed, the same prompt here. And this is from the control net. I'm passing this over to the Flux dev as a second pass, as a refiner stage, and it comes up with a higher resolution image. Now, some of you may get an out of memory error because we are first loading this depth model, and then we have to load the Flux dev model as well. So if you get an error, I've also made a modification where you can change the second model and you can simply change it to an SDXL model. This section here is just an image to image. So we can go from Flux to SDXL in this particular case. And of course, we'll need to make some changes to the workflow. For example, we'll need to add a positive and negative because the positive and negative that we have for this K sampler is being generated by this instruct pix2pix. And the usual SDXL doesn't know how to use it. Those are minor changes, but once we have that, we'll go from this as the control net to this as the SDXL. And how about going from SDXL into a second refiner? So we'll go from this output to this output. The denoising strength is a little bit too high, so we can decrease it down a little bit. So we have this one a bit more defined, but now we can also pass it to a flux as our final refiner. And if you want to, you can also upscale the image because flux can work up to 1024 by 1024. It can even go higher depending on the amount of VRAM that you have. So once you make the modification to it, so we'll go from this to this as flux one, and the upscale version, we can refine this upscale version to get this as well. So here's another example where I'm using person doing skateboarding. This is the control net output. It's only 5 steps, but we pass that over to, in my case, I'm passing it over to an SDXL. This is the first pass. This is the second pass. And then I pass that over to flux. And as you can see, the image size grew bigger. And then we refine it a little bit more to have more shape. Now here's another one. This is a depth of a close-up portrait of a woman. So we take this, we pass it through the control net, and the prompt was a vampire female lady. We have the control net generated output, and we do the same thing. So we pass it over to any of your model. You can do flux, you can do SDXL, you can do SD 1.5. It doesn't really matter as long as you like that particular style. In my case, I'm using the SDXL model. First pass, second pass, upscale it, and then pass it to flux at the end. And here is the final result. We still have the same shape, and the depth model is still being applied even though we are doing so many passes. Here's another one. Again, this one is a portrait of a woman, and in this particular case, I'm still using the same prompt. The control net here, we go to SDXL, second pass, upscale, and then flux. Here's another one. I'm sure you get the point. We can go from normal, realistic to anime. So I'm just going to move on. This is the final flux version. And if you want to, you can also go from realistic to realistic as long as you have the model. So control net, we get the same thing. We go with SDXL, first pass, second pass. We have the upscale version, and then we have the final with flux. I usually prefer to have the flux as the last refiner model because it's going to add quite a few detail that normally SDXL or SD 1.5 cannot do. Here's another one. I'm still using the same input image, the depth input image. And in this particular case, I wanted some kind of cyborg. This is my control net by flux. Here's the SDXL, first pass, second pass, upscale, and then the final result. Again, I'm just going to go through some of these examples so you can see how it's changing. We can also change the gender. And in this particular case, I'm still using that female control net depth output. I've just changed my prompt to output a man instead of a woman now. So as you can see, it's still able to get the shape, but it's changing into a man. You can do any art style, any variation using the same method. And in case you're wondering, yes, it can do hands. You just need to get the depth map of a hand. And here's the control net part. As you can see, just 5 steps. We pass it over, first pass, second pass, upscale, and then the flux version. We have really good quality here. Now you can change this to a different style. As you can see here, I have some kind of robotic arm here. Now you don't need to go like this. I think I went overboard just playing around with it. You can just do one with this depth model. Just have your input image here, and you will get this first output by the control net. Only 5 steps. Just do an image to image, then you can just have one image to image instead of like me. I'm basically going from the control net, which is going to give me the first output, SDXL, first pass, second pass, and upscale, and then a refiner. I'm doing 5 things here, but you don't have to do 5 things. You can just do just 2. And if you're satisfied with that result, that's fine. The main thing here is just knowing that this depth model is a checkpoint merge. So it is inferior compared to the flux model. You cannot just use it on its own. Now, sure, if we go back to this example here, let's say I wanted to generate an image that will only use ABCD. And since ABCD is in the model here, we'll be able to generate it. But the moment I want to generate something that is AXY, since we don't have XY here, we're not going to get good result with it. And that is the reason as to why I'm going from this dep model into an image to image workflow. So with this, you should be able to modify this workflow based on your preference. And hopefully now you can use the Flux ControlNet. I've shown you the dep one, but you can also do the Canny version. It's basically the same thing. In the workflow that I'm going to provide you, I will also add this ControlNet, the dep anything ControlNet, and this is what I'm using in order to get the dep map of my input image. If you are not aware of this ControlNet auxiliary preprocessors, my last video I explained these nodes extensively. I even have a pre-processed workflow that I've shared there. Quickly, in order to install this custom node, you'll need to go into the manager, and you can click on install missing custom nodes if you are loading the workflow I'm sharing with you, or you can go into custom nodes manager at the top here, search for ControlNet, and then install this one here, the ComfyUI ControlNet auxiliary preprocessors. And that's about it. All right, so hopefully now you know how to use this Flux.1 dep dev FP8 and the Flux.1 Canny dev FP8 version. All right, so thank you for watching until the very end. Have a nice day. Take care. Happy New Year once again. I will see you in the next one.